Hi, I'm Jamie Betts, your instructor for AMP2. We're continuing with our potty talk. As we move through our digestive system lecture, this section is going to cover elimination of waste from our digestive tract and some of the other details involved in those types of reflexes. This is where we left off in the last lecture. So we were just talking about mass movements and this idea that stimulation in the upper GI tract is going to stimulate the lower GI tract because of these reflexes that are involved in our enteric nervous system, in this little kind of network of nerves and feedback loops that are within our digestive tract. So let's talk about some of the characteristics of our intestinal wall, which make it suitable for the function that it has. First of all, our large intestine does not have villi like our small intestine. There are rather intestinal glands scattered throughout the large intestine, mostly dominated by mucus cells. The mucus cells are going to secrete mucus to basically lubricate this undigested food. Because remember, one of the main functions of our large intestine is to reabsorb water. Well, when you dehydrate this undigestible material, it's going to get very tough and hard, which is going to make it very difficult to pass through and slide through the rest of our digestive tract, the rest of the colon and the rectum. So the mucus glands are going to actively secrete mucus to help it move along much more easily. The mucosa does not have any enzymes, unlike our small intestine, which was packed with enzymes, brush border enzymes, pancreatic enzymes, and so on and so forth. There's no enzyme action here in the large intestine. So here you see our lumen. It's very flat. We do have those glands with the mucus secreting cells in them, secreting onto the lumen. And again, simple columnar epithelium throughout. Some of the special characteristics of the rectum, the anal canal is the distal portion. This is where there's actually longitudinal folds called anal columns. This allows for the expansion of this cavity during defecation. And there's a special network of veins within the lamina propria and submucosa of this area to help increase the blood flow to this area to allow for the muscular contractions that will occur with defecation. When there's too much venous pressure, those veins can become distended, and that is what a hemorrhoid is. They could actually be internal or external. I mean, they're actually protruding out of the anus itself, very uncomfortable. This can be caused from pressure in pregnancy or pressure during defecation when you're squeezing and bearing down to remove the feces. It could cause the increased venous pressure, which can cause a hemorrhoid. There are sphincters involved in the rectum as well, an internal anal sphincter and an external anal sphincter. The internal anal sphincter is actually an involuntary muscle. It's smooth muscle. You can't control it. The external anal sphincter is under voluntary control, luckily, so that we are not walking around wearing diapers. The anus is the opening to the external environment. The epidermis here is keratinized, just like the rest of our skin and like our lips, right? It kind of has a darker color to it. It's pigmented because of the keratinization. See, the anal columns will allow for the expansion, just increased surface area, internal sphincter and external sphincter. So when you have to go, and you're like, I need to go now, that's typically when this internal sphincter has relaxed and you're solely relying on that external sphincter to hold it all in until you consciously say, okay, I'm sitting on the toilet. It's an appropriate time to go to the bathroom. So let's talk about the absorption that happens in our large intestine. Again, not a whole lot, less than 10% is happening here. The stuff that is being absorbed are particular vitamins, which is why people who have issues, I'm thinking of like diverticulitis, where individuals will have severe inflammation in their colon and have part of their large intestine removed. If they have enough of their large intestine removed, then they'll have to be on vitamin supplements because of this decreased vitamin absorption that will occur. Biotin, B5, vitamin K, these are all vitamins that are produced by the normal bacteria that just live in our colon. They're symbiotic. They just live there. We also have water reabsorption occurring that's going to help prevent dehydration. So 1.5 liters or 1,500 milliliters enters our colon every day, and over 1 liter goes right back into our body. So less than 200 is actually ejected, unless you're sick or your bacteria are out of balance or whatever, and you might have some diarrhea or loose stool, which can be dangerous, and you have to increase your water intake to offset that. So let's talk about the composition of feces. Since you always love, where you're like, I cannot wait to learn about the composition of feces. Right? What is this stuff made of? It's made of 200 milliliters of, it is ejected every day. 75% of it is water, believe it or not, even though it feels like, I don't know if you've ever picked it up. Other than wiping, my children and when they were younger, obviously the water content is a little larger in smaller children as their digestive tract is adjusting. The majority of it is undigestible material, inorganic matter, remains of epithelial cells that have been wiped away, literally, as that food passes through. And it's also made of bacteria. The components of the bacteria is what contribute to the odor of our feces. So ammonia, the nitrogen-containing compounds, hydrogen sulfide, which is that kind of rotten egg, stinky smell. So those are all you can thank your bacteria for those wonderful smells that come from our bodies. So vitamin K, vitamin B5, biotin, and water are the main ingredients that are reabsorbed. Urobilinogen, toxins, etc., all secreted and recycled by the bacteria that are living in our colon. Sorry, I lost my train of thought. So some organic waste products are actually used by the bacteria, or some of them are reabsorbed back into our body after they've been modified by the bacteria, and very small percent of the substance that enters our large intestine is actually excreted. All of this is controlled through reflexes. You have a long reflex and a short reflex. Remember the difference between these. We mentioned long and short reflexes before. Long reflexes are coordinated by our central nervous system. Short reflexes are just within our digestive tract altogether. So the defecation reflex starts once that rectal wall begins to distend when the feces arrives. Stretch receptors basically trigger this. And then there's 2 positive feedback loops. The long reflex is coordinated by parasympathetic, the sacral plexus, right? Stimulating that mass movement, pushing the feces forward, getting it into the sigmoid colon and into the rectum. And then the short reflex is going to stimulate the sigmoid colon and rectum to contract and push. So the relaxation of the internal anal sphincter is going to help move that feces into the anal canal, and that's that feeling of, I gotta go now. Without voluntary stimulus, the external sphincter is going to remain contracted and tight, thank goodness, and then the relaxation of that external anal sphincter is what allows the defecation to occur. So here it all is in step-by-step. And what I would do, again, is I would try to create a flow chart of this. Have all of these terms basically on an individual note card or on a Post-it. See if you can put them in order. See what happens next. Notice it's a kind of a cycle. So one thing leads to another, and eventually gets back to the beginning because it's a reflex. So you have one thing affecting another. But that's what I would do to learn this lesson, and maybe even color code the long versus the short reflex. You can pause. I think I'll stop the video here because then we move on to a next section. So you can stop the video there, review those 3 questions, and we have a couple more lectures to go before we finish this chapter. Bye.